Now we are going to see about the interpreted design pattern, theory, principles, real life examples. In the next video, we will try to cover the interpreted design pattern Java implementation. So if you want to buy software design patterns book, you could buy the book using the product link, which is the description box of this video. So let's come to this point. So interpreted design pattern. So in our real life, in our daily life, we would have been using interpreter at various points of the time. For example, if you are using Google Translator, which is one of the important and best examples for interpreter. If you give in English, if you want to convert that English language to some other language like Telugu, Tamil, that Google Translator will do for us on behalf of us. Here, that Google Translator is acting as an interpreter. So it interprets some input to some other output. So this is the first point. It provides way to evaluate grammar or expression. So in our real life, Google Translator has set of grammar. So for example, for English there is a set of rules, for Tamil there is a set of rules, and for all the languages there are a set of rules. Using the rules only we will try to talk with others. So similarly, if you are writing any program which contains set of rules or grammars, then we could use interpreted design pattern for that. And then useful for developing domain specific languages or notations. If you are writing a program for one specific domain, if you want to extend that to some other application without adding any other things, then you could use the interpreted design pattern. So we will try to cover this point using real life using Java implementation in the next video. And then ability to define a language grammar. If you're developing any language like Java, C++ and some other languages, then you could use the interpreted design pattern to design the language in such a manner that could be easily extended, reliable and scalable. And then Java compiler that interprets Java source code into bytecode. So here in our daily life we would have been using interpreter in Java itself, because Java code is interpreted into bytecode using compiler. This compiler will convert the Java source code to bytecode. Here the compiler is acting as an interpreter which converts the source code to bytecode, and then after converting to bytecode, that could be consumed by n number of JVM machines, so Java virtual machines. So for example, if you are trying to execute bytecode in Windows, Linux and Mac, the output should be same. If you're executing in Windows, you shouldn't get irrelevant output. All these platforms should get the same output. So that's why Java is called platform independent. Here interpreter is acting at two ends. One is at the compiler end and also one at the JVM. So here interpreter is used to convert interpreter which is in the compiler, which is used to convert Java source code to bytecode, and then interpreter which is in JVM, which is used to execute the bytecode at various platforms. So in our real life itself we are using interpreter at various points, and then defines a grammatical representation for a language and interpreter to interpret the grammar. So for example, if you are designing a big complex grammar, so in that it involves n number of rules, means then we can use the interpreted design pattern to design those things. And then this interpreted design pattern is widely used in compilers. If you want to build any compiler, your custom made compiler, then you could use interpreted design pattern to design the compiler. Using that interpreted design pattern, you could design a compiler in such a way which can be easily extended. So that's the power of interpreted design pattern. We will try to cover this interpreted design pattern Java program in the next video. So please don't skip the next video. Thanks for watching this video.